Can you truly comprehend this cosmic monster? Let's be honest, probably not. And that's not a failure on your part. It's a clue to just how bizarre our universe really is. We hear the terms all the time: event horizon, singularity. But these aren't just vocabulary words for a science test. The event horizon is the point of no return, a one-way door in the fabric of space-time. And the singularity? It's the place where our understanding of physics, of everything we know, completely and utterly collapses. It's a point of infinite density, where space and time cease to mean what we think they mean. Even with incredible images from the Event Horizon Telescope, we're only looking at the shadow, the silhouette of the abyss. The true nature of what lies within remains a complete mystery. To understand the challenge our brains face, let's talk about scale. Imagine our planet, Earth. Now, picture Sagittarius A, the supermassive black hole at the center of our own Milky Way galaxy. To compare them, you'd have to shrink the Earth down to the size of a tiny pea, and Sagittarius A would still be a sphere the size of a giant sports stadium. And that's a relatively small, supermassive black hole. Some, like Ton 618, are so massive they make our sun look like a single grain of sand in a desert. Now, let's get even weirder. Imagine the density. If you took our entire solar system, with the sun, all the planets, everything, and crushed it down to the size of a single sugar cube, you still wouldn't be close to the density of a singularity. It's an idea that our minds simply aren't built to handle. And if you got too close, you'd experience something called spaghettification. So why is this so hard to picture? The answer is in our evolution. Our senses, our brains, everything about us evolved to survive on a big rock, orbiting a medium-sized star. We're programmed to understand throwing a spear, finding shelter, and navigating a landscape. We are masters of the macroscopic terrestrial world. Our perception is fine-tuned for a reality where gravity is a constant, gentle pull, and time flows forward at a steady, predictable pace. Phenomena like gravitational lensing, where a black hole's immense gravity bends light so much that you can see stars that are directly behind it, don't fit into our evolutionary toolkit. We didn't need to understand warped space-time to avoid a saber-toothed tiger. So we rely on imagination and abstract thought to try and bridge this gap. We create incredible computer simulations, stunning works of art that try to capture the chaos and the beauty. But it's crucial to remember that these are all just interpretations. They are translations of complex physics into a visual language our primate brains can begin to process. We aren't seeing the black hole, we are seeing a model of it. This raises a fascinating question. Is our inability to truly feel or see a black hole just a biological limitation, something we could overcome with a more advanced brain? Or does it point to something deeper, something fundamental about the nature of the universe itself? What if some things are just unvisualizable? This is where science hands the baton to philosophy. If we, as a species, can't fully grasp one of the most fundamental objects in our cosmos, what does that say about our quest for ultimate truths? It forces us to confront the possibility that our entire framework for understanding reality might be incomplete. Scientists are exploring mind-bending theories to try and make sense of it all. Ideas like the holographic principle suggest that our three-dimensional reality might just be a projection from a two-dimensional surface, like a cosmic hologram. Other theories propose the existence of extra dimensions, curled up and hidden from our senses, which might hold the key to understanding what happens inside a singularity. These aren't just wild guesses. They are serious attempts to build a new language, a new kind of physics, for a reality that is far stranger than we ever imagined. It leads to a profound thought. Perhaps some aspects of the universe aren't meant to be fully understood by human consciousness. Maybe our minds have a cosmic event horizon of their own, a boundary beyond which pure comprehension is impossible. What if the universe contains truths that we can describe with math, but never truly intuitively know? But here's the beautiful twist. This limitation isn't a failing. It's not a reason for despair. It's an invitation. It's an opportunity for endless awe and relentless exploration. The fact that black holes exist and that they challenge the very limits of our minds is what makes them so compelling. The pursuit of understanding them pushes us to be better, smarter, and more creative. It drives us to build incredible instruments like the Event Horizon Telescope and the James Webb Space Telescope. It forces us to invent new mathematics and to question our most basic assumptions about existence. Complete understanding might always remain just out of reach, a shimmering mirage on the cosmic horizon. But the journey, the chase, is everything. Black holes remind us that the universe is not just a problem to be solved, but a mystery to be lived. They are a testament to the profound beauty of the unknown and a promise that our grand, magnificent journey of discovery has only just begun. Thank you so much for exploring the limits of our universe and our minds with me today. If you enjoyed this journey into the abyss, please hit that like button and consider subscribing for more deep dives into the cosmos. See you in the next one.